Hello there, Mr. Sutton here, bringing you the IM322 Part 1 homework solutions on greatest common factor. For this problem, to simplify this, we need to split up, kind of distribute this division. So I can rewrite this as 12x over 4 plus 20 over 4. And now I'll just do each of these separately. 12x over 4 is 3x, and 20 over 4 is 5, so 3x plus 5. On this problem, we're trying to divide this polynomial by 3y. So to do this, we basically have to distribute 3y division to each of these three terms up here. So we've got 15y cubed over 3y, and 6y squared and 3y up here also get their own denominators of 3y, like so. Now that we've split this up, we can tackle each fraction individually. So for the first one, 15 over 3 is 5. Y cubed over y, we're using our exponent rules. So we're going to subtract, if we're dividing the bases, we'll subtract the exponents. So this is going to be 5y to the 3 minus 1, 5y squared. Next, this is going to be 2y. Y squared over y just cancels one of the y's and gives us a y. So 2y there. And then 3y over itself is just 1. On this problem, we're trying to divide this polynomial by 2km squared. Since I'm dividing all of this stuff and everything up here is being subtracted and added, I can actually distribute this division and split this up into 6k squared m over 2km squared minus 12k cubed m squared over 2km squared, and also this 9m cubed also gets its own denominator of 2km squared. So we're dividing every single term by 2km squared. All right, just going from left to right using our exponent rules. For this first one, 6 over 2 reduces to 3. K squared over k just gives us a k in the numerator. M over m squared gives us an m in the denominator. So we have a 3, a k over m. And then for this next one, we have, 12 over 2 is 6. This is going to be a k squared in the numerator, and the m squareds cancel out completely. So this is going to be minus 6k squared. And then for this last term, can't reduce 9 over 2, but we can reduce these m's. So we're going to have an m to the first power in the numerator. Remember, when you divide bases, we're subtracting the exponent. So this is 3 minus 2. So we end up then with 9m over 2k that we're adding. For this problem, we're trying to factor this expression. So let me first look for common factors. 3 and 12, those are both divisible by 3. And we have an a squared and an a to the 4th. Those are both divisible by a squared, the smaller of the two exponents. So I can take out a 3a squared when all is said and done. And that's going to leave me, 3a squared, dividing that by 3a squared. That's going to become a 1 inside the parentheses. And then 12a to the 4th divided by 3a squared. 12 over 3 is 4. A to the 4th over a squared. Subtract the exponents. That's going to be a squared. So 4a squared altogether. And this is factored. In order to factor this one, we have to look for common factors. The coefficients are 1 and 4, so there's nothing we can really take out there. In terms of variables, these both have b's. In fact, they both have b to the 20th power. So we can take out a b to the 20th power. And now I'm just going to put inside whatever's left when I divide each of these terms by b to the 20th. So for the first term, that's just going to be a left over. And for the next term, that's just going to be plus 4. For this problem, we have to factor this as far as it'll go. So we're going to be taking out a common factor. First, we look if there are common factors. Looking at the numbers, 15, 24, and 36, those are all multiples of 3, so we can take out a 3. And for the variables, we have x's in all of these terms, and the lowest exponent is x. So that's the biggest thing that we can take out is an x to the first. So I'm going to take out a 3. I'm going to take out an x. And now inside my parentheses that I'm about to write is going to be whatever I get when I divide all of these things by 3x. So 15x cubed over 3x, that would give us 5x squared. And so if you multiply 3x and 5x squared together, you would get that 15x cubed back. Now if I take 3x out of 24x squared, that gives us an 8x that we're adding. And then 36x divided by 3x is just going to be 12. X's cancel completely. So that is our factorization for this. In order to factor this one, we have to start by taking out a common factor. It looks like 15, 5, and 40, all those coefficients are divisible by 5. And in terms of variables, these all have r's in them. The lowest degree is r to the second, so that's the biggest r that we can take out of all of them. So taking out a 5r squared then, let's see what that leaves me with if I divide each of these terms now by 5r squared, and then just put the leftovers in the parentheses. 15r to the 10th over 5r squared. 15 over 5 is 3, and we subtract the exponents, so we're going to have r to the 10 minus 2, so r to the 8th, so 3r to the 8th. And then we've got 5r to the 8th divided by 5r squared. So the 5's cancel. We have r to the 6th that we're subtracting there. And 40 over 5 is 8, and we have r squareds canceling out, so that's just going to be plus 8. And this one is done. On this problem, we're trying to factor this expression. So first we look to see if there's a common factor we can take out. So looking at our numbers, our coefficients, we've got 4, 8, and 15. So those don't have any common factors other than 1. I mean, we have even numbers versus an odd number, and the even numbers aren't divisible by 3 or anything crazy like that. How about the variables? Well, we have an a, a b, and a c. We don't have any duplicate variables, certainly not any variable that shows up in all 3 terms. So there are no common factors whatsoever that we can take out of this. Since we can't factor this, we're going to just call this one prime, which means no factors other than 1 and the thing itself. On this problem, we want to know which of these expressions is equivalent to 5k plus 50 over 5. So the key on here is realizing that everything is being divided by 5. We're basically distributing division by 5. So I could rewrite this if I wanted to as 5k over 5 plus 50 over 5, so split up the fraction basically. And then just reducing here, 5k over 5, that just reduces to k, and 50 over 5 is just 10, so k plus 10, which gives us answer choice A.